Hello everyone, welcome to the day 2 tutorial of Google Intensive Training on AI Agent. In the Unit 2, we again have two exercises as Day 2 Part A and Day 2 Part B. In this specific video, we will be covering Part A. As mentioned for the previous videos, even this assignment has a summary podcast episode, which you can click here and go to listen to it. This is created by Notebook LM. I will also put a link of this in the YouTube description of this video. Besides that, I'll also put the link for this white paper in case you have not gone through it. Please go through it after a code lab. This will help you in the long run because the information that it has is very helpful. Now, this assignment is about exploring the new tools to extend what an agent can do, and then go to the best practices for those tools, including using MCP and long-running operations. I'm clicking on Explore to go to our first exercise of this day 2. This creates a notebook for us. Now we are redirected to a non-editable notebook. We'll click on Edit My Copy from the right-hand side on the top. This opens an editable copy for us to run our codes. What are we going to do in this course? In this course, we'll learn how to create agents with built-in tools like Google Search. We'll turn a Python function into agent tool, then we'll build an agent tool, use it as a tool for another agent, build our first multi-tool agent, and explore different tool types in ADK. So this is the section 1, where we'll be setting up our environment. As we are using Kaggle environment, we don't need to install the Google ADK library for Python. If you're using an outside environment, then please install this. Coming back to configuring, as we have done in our previous videos for the previous assignments, we'll go to add-ons, click secret. Now this is already selected. Usually sometimes when you click secret it would be unset, so just check if it is set or not set. If not set, then set it and then run this code. I've explained this code already in the past 2 videos, so I won't be talking about this anymore. So we have set up and authenticated the key successfully. Now we'll import the ADK components. Over here we see 2 more imports other than what we were doing in the last 2 videos. Over here, I'll run the code first, and by the time it executes, I'll tell you what it has. So earlier, the agent we have is an LLM agent now. Google LLM model that we're using is Gemini. The runner that we use is in-memory runner. The sessions that we're going to use here is in-memory session service. We were working on Google Search so far in all our exercises. Now we have got agent tool and tool context as well, which we'll be using in our upcoming codes. And then we have a built-in code executor as well, which we will use for built-in calculations that the agent will be using. I'll explain more in detail when we go to the respective step. So ADK's components are imported successfully. Now we'll run this helper function. We only do this if we are using Kaggle, but if we are in an outside environment, we don't need to define this function. This is done. Now the configure retry option. You may not see the print statement in your code. You can type it yourself. I do it because I want to understand that this runs. With this, the setup is complete. Now we go to the section 2. In section 2, we'll first understand what are custom tools. In day 2 assignments, we were using the built-in tools, which are very generic and could not be used for any custom business logic or any unique requirement. The generic tools might not be able to handle them exactly as the requirement would be. So in order to resolve that problem, we have these custom tools that give us complete control over the functionality of the tool. ADK provides multiple custom tool types to handle such scenarios. If you want to know about them, you have an article towards the end of this section which you can go through. I'm also going to put that in the description so you can read it from there as well. So the example that we are using here to demonstrate how to build a custom function tool is a currency converter agent, which means this agent can convert currency from one denomination to another and calculates the fees to do the conversion. Over here, we would need two custom tools. One is get fee for payment method and another is get exchange rate. This tool will find transaction fees for the conversion, and this tool will get the currency conversion rates. Now, the flowchart works in a way that the user will provide a prompt that he or she wants to convert XYZ currency into XYZ, and the currency agent will refer to the observations coming from these two tools and provide the output to the user. Over here, the currency agent will be doing the math by itself. Now, how do we define a tool? So a tool is basically a Python function that becomes an agent tool. And over here, we'll create a Python function. We'll follow the best practices that are listed here. And we'll add that function in the tools list. So what are the best practices that we need to follow when we create a Python function? Dictionary returns. We need to include dictionary returns, which returns the status of the tool, whether it's successful or there is any error message. We need to mention clear docstrings because LLMs use docstrings to understand whether and how to use a tool. We'll be using type hints like dictionaries, string, etc. because that enables ADK to generate the proper schemas. And then we'll also add the error handling statement because that helps us to structure error responses and that will help LLM to handle the failures gracefully in case of error, what an LLM is supposed to do. So this is something that we will be incorporating in our Python function so that the tool becomes reliable and easy for LLM to use correctly. This is the code here for the first tool, that is get fee for payment method. Over here, we are describing the instruction as this function will call when this function is called, it will look up the transaction fee percentage for the given payment method. This tool simulates looking up a company's internal fee structure based on the name of the payment method provided by the user. The argument is name of the payment method. It should be descriptive like platinum credit card or bank transfer. And upon receiving that, it returns dictionary with status and fee information like status is success when the status is success and fee percentage is 2%. And error would be displayed or return when the status is error. The error message would say the payment method not found. So in case if it is not giving us a reliable payment method, it will throw this error. Then we'll also mention the fee database, which we mentioned here. The fee database is basically if it is a platinum credit card, then it's 2%. For gold and debit card, it's 3.5%, and the bank transfer is 1%. Now we need to bring this data on two conditions. One, if the fee is not none, like you have some value, then the return status would be success and will show the percentage fee. Okay, and if the fee is none, in that case there would be error, and the error message would say the payment method and whatever method was input by the user will show up here saying not found. Now I'm going to run this. I'll hit Shift Enter on the keyboard and this is done. You can, as mentioned previously, you can hit on the play button here to execute the code snippet. Otherwise, Shift Enter will do the same thing. Now here we are defining the next tool, which is get exchange rate. Over here, the basic currency would be string and the target currency would also be string. What the dictionary says here is this tool, when called upon, will look up and return the exchange rate between the two currencies. Argument is the base currency is the currency code of the currency you are converting from, like from USD to INR or USD to Japanese yen, XYZ. And target currency is the currency code of the currency you are converting to, like Japanese yen in the previous example I mentioned, or USD to INR, then INR is your target currency and USD is your base currency. Now it returns success when the status is success and the rate is For example, the rate is 0.93 of sort. An error, it will mention error, and the error message is unsupported currency pair. So it will give you the rate, what rate they want, and then that number, and then they'll give you the error message in case if it's not having the required information. Now, how the rates are set. Over here, I said 0.93 because that's the rate for euro. Japanese yen has 157.50 when we are going to convert it with USD, and INR is 83.58 as of today, I think, yeah. Now we'll validate and process the input, the base currency and target currency. We have defined these functions. Now we'll structure the rate result, the result with the status. So we'll say get the base and get target. So if the rate is not none, which means it's a success, and we'll show the rate. If the rate is none, then it shows an error, and it throws error saying that unsupported currency pair, and mentions the currency names, the base currency and the target currency that has been input by the user. I've run this as well. Now we have created the function tools or the agent tools. Now we need to create the currency agent for which we will be using these agents. So the currency agent, we have defined the name, model, which is just as any other model, any other currency agent, any other agent that we define. Then the instructions as we give to any other agent. The instructions here are: you are a smart currency conversion assistant. For currency conversion request, use get fee for payment method, or use get exchange rate to get the currency conversion rate. Check the status field in each tool's response for errors. Calculate the final amount after fees based on the output from this and this methods, and provide a clear breakdown. First, state the final converted amount, and then explain how did you get that result by showing the intermediate amounts. Your explanation must include the fee percentage and its value in the original currency, the amount remaining after the fee, and the exchange rate used for the final conversion. If any tool returns status error, explain the issue to the user clearly. So now, when we're talking about you have to use this tool and use this tool, we have to define those tools here. And so we have mentioned both the tools inside the tools info. And we'll be printing these statements when we run. Now, we'll be testing the currency agent. So we'll create a runner. It runs the currency agent, and I see the responses. So we'll say response, and there's a default value saying I want to convert 500 USD. So this was, I think, previously on. I was trying this at my end, so the numbers changed, but I think it was I want to convert 120 US dollars to INR. Using a platinum red card, how much will I receive? So now I'm running this. It started a new session. It says user has asked this question. You can ignore this error because if you rerun it, this error will vanish. Now it says currency agent responded saying that I'll receive these or much amount, and this is how you calculate it, saying that your platinum card, it has a 2% fee. Amount is 1250 USD into 0.02, which becomes $25. Amount after fee deduction is 1250 minus 25, which is 1225. Currency conversion, the exchange rate from USD to INR is 83.58. Hence, you multiply these two and your final number becomes 102,385.50 INR. Now moving to section 3. Over here we are talking about how can we improve our agent's reliability with code. Because when we give a math calculation to LLM, it's not necessary that you can rely on LLMs for mathematics. They can make calculation errors or can use inconsistent formulas. Hence, we are asking the agent to generate a Python code to do the math and run it to give us the final result. In this case, code execution is much more reliable than letting the LLM try to do the math by itself in its head. So if you compare this with the previous, the flowchart that we were discussing, the enhanced currency agent was a simple currency agent with calling these two functions or the agent tools. Over here in this new model, the improvised one, you see that the currency agent is also interacting with the calculation agent, not a tool. Please make sure that these two are the tools and this is an agent. And the agent is interacting with a built-in code executor to do the Python coding to get the results. Hence, we have changed the name of currency agent to enhanced currency agent. So ADK has built this built-in code executor which is capable of running code in a sandbox as well. You don't need to have a production environment. And please note that this uses a Gemini's code execution capability. Now let's go ahead and create this calculation agent and see how it uses the built-in code executor. As the format for every agent, you will define the agent, you will write the name, model, and retry options. That's what we have done for calculation agent. Then we give it an explicit exclusive instructions on what is the expectation from this agent. Here we're saying that you are a specialized calculator that only responds with Python code. You are forbidden from providing any text, explanation, or conversational response, which means this calculation agent would not be interacting with the user or taking control over from the enhanced currency agent and go to user bypassing this agent. Now, going to the rules, it says that your output must be only a Python code block. Do not write any text before or after the code block. The Python code must calculate the result. The code must print the final result to stdout. You are prohibited from performing the calculation yourself. Your only job is to generate the code that will perform the calculation. And failure to follow these rules will result in error. Hence, it's supposed to use this code executor, that is built-in code executor. Okay. Now, this was not there in the code, and I had incorporated it because when I run it, I want to know that it ran successfully. Next step is that we'll update the agent instructions. We have created this part, the calculation agent. Now we need to integrate this calculation agent, incorporate it into the currency agent's instructions. So in this instructions, we are going to tell the currency agent that now you generate a Python code to calculate the final amount and use the calculation agent to run that code and complete the final amount. You are not doing it by yourself, which was like a big math instruction last time. And in the tool, earlier, if we go through the previous tool, it has get fee payment method and get exchange rate. Over here, your tool is not only just get fee payment and exchange, but the agent tool as well, as shown in this diagram, all three. So every time a user prompts sends a prompt asking for a conversion information, the agent will get in contact with these three tools and go back to the user with the final output. So I'm running this now. I've run this, but I think I missed to explain the instructions. Let's go through the instructions then. So here we are saying that you are a smart currency conversion assistant. You must strictly follow these steps and use the available tools. For any currency conversion request, you get the transaction fee, get exchange rate, check the error, calculate the final amount, which is critical. And we are explicitly mentioning that you are strictly prohibited from performing any arithmetic calculations yourself. All right, like the previous agent. Now we provide detailed breakdown and summary. You must state the final converted amount and then explain how you have done all the calculations, just like before. Now we'll run this runner. We are naming it as an enhanced runner, and we are using the enhanced runner agent. This is done. Now we'll test the agent and see if it answers properly. So convert 1250 USD to INR using a bank transfer. Show me the precise calculation. Please do not worry about this warning. This sometimes happens if there are many notebooks or sessions running, and if you rerun this will go away. So yeah, over here it says convert this. So the enhanced currency report agent says the conversion of this to this. Here's the breakdown. It is 1,04,140.5, and the breakdown is the transaction fee for bank transfer is 1%, so the amount is 12.5. After deducting the fee, it becomes this much, and with the exchange rate of 1 USD to this, the final amount is this. So this gives an answer. Now let's see how it has passed the Python code that it generated and how did the calculation agent has calculated this using the built-in code executor. We can do this running the helper function that we defined in the beginning. And now you see here, generated the Python response. USD is this much, exchange rate and fee So it has calculated the transfer fee amount INR, and it says print INR amount. Then it has generated this fees again, and then it has pre-printed all this information about the rate transfer, and this is how you have got these numbers in your response. I'm sure that few of you would have this question: what is the difference between agent tool and subagents? Because in our previous code labs we were using subagents along with functional tools, and over here we are using agent tool, which look like it's working in a similar fashion, but that is not correct. They work very different. Let me tell you what is the difference over here. Before I mention this, let me give you an example from the past videos that we have gone through. So if you remember the flows, the different patterns of workflow we were going through in the previous video, part B of day 1. The sequential flow is basically a dependent flow. The input of the output of A is input to B, and the output of B is input to C. Over here, you notice that the user has sent the prompt to agent A, but towards the end, the final answer is provided to the user by agent C. So, which means agent A has lost the control, okay, and now agent C has taken the control of the conversation. This is what you have in subagents, okay, whereas with agent tool, it does not happen that way. If we go back to this flowchart, you notice that this is the whole and sole agent who's interacting with the user, though it is going back to this agent, getting the calculations and coming back and sharing it with the user. It's taking its help, but it's not losing the control over the user. So if I come back here and read this now, this will make better sense to you. Agent A calls agent B as a tool. Agent B's response goes back to agent A. Agent A stays in control and continues the conversation, which means the use case in real world is delegation for specific tasks like calculation in this scenario. Subagents, which is like different pattern, which we have done in our previous exercise. Agent A transfers control completely to agent B. Agent B takes over and handles all future user input. Agent A is out of the loop. So the use case is handoff to specialist, which is like, in customer support tiers, you have a level 1, level 2, level 3, like that. Now in our example, we wanted the currency agent to get calculation results and continue working with them. So we use agent tools and not subagents. Hope this makes clear. So now we are at this section 4 of this exercise, which is complete guide to ADK tools. In this, we'll understand the type of tools that ADK toolkit provide. Basically, there are two categories. One is custom and another is built-in. What is a custom tool means? As mentioned earlier, it's basically you have control over the functionality. You will build exactly what your agent needs to do for you. And examples are function tools like the ones that we use in example today. Then you also have long-running function tool, which means that it helps in file processing, human in the loop approvals. So the advantage of using is that the agent can start this task and then continue with other work while waiting for the file processing or waiting for this task to complete. Then MCP tools we have, and we have OpenAI. So agent tools is something that we have just done. So that's like a specialist agent, and we can reuse it across different systems since we have now defined it. So it's in our system. MCP tool is tool from model context protocol servers. Examples are Google Maps, databases, all that. So the advantage is that when you can connect to any MCP compatible service without looking out for any custom integration. Last but not least, it's OpenAPI tool, which every one of us know. It's about the REST API endpoints that become callable tools. Advantage is that no manual coding is required. We just need to provide an API spec and get working with the tools. Now going forward to built-in tools. Built-in tools, as the terms say explains it. These are like the pre-built tools provided by ADK Toolkit. The advantage of this is like you can use them immediately. They don't require any setup. You don't need time to develop them. Gemini tools, the one that we have been using in our exercises until now. And then comes Google tools. Google tools are basically the BigQuery toolset spanner, API hub toolsets, etc. etc. The tools basically the ones for Google Cloud Services and enterprise integration. Last but not least, the third-party tools such as GitHub and Hugging Face. So advantage of using these tools is you can reuse existing tool investment. You don't need to rebuild what already exists, right? So what we do here is that these are like wrappers for existing tool system. So yes, congratulations, we have successfully completed day 2 part 1, wherein we have learned how to build agents that go beyond simple responses to take intelligent actions with custom tools. Please continue to the next video to learn about the tool patterns, which is the assignment part B of day 2. Thank you.